This video shows how to set up the FieldFox for looking at wireless LAN and Bluetooth and Zigbee and other pulsed short duration transmissions. So the first thing you'll need to do is to connect the whip antenna via the couple of adapters to the 3.5mm connector on the right hand side of the FieldFox analyzer. Next thing to do is to turn the power on, and the machine will go through a boot up sequence which will take just a few seconds or so. If you've been using the instrument, you can avoid having to go through the entire reboot process. If you press the power button, it'll have an option for standby as opposed to shut down. So we'll come back when it's booted up. Okay, so this is the default boot up of the instrument, and it boots up into what's called the cable antenna tester mode. So the first thing you'll want to do is switch it to the spectrum analyzer. So this has two different types of spectrum analyzer, a standard spectrum analyzer and a real-time spectrum analyzer. I'll first show you what you will see for these types of transmissions in the standard spectrum analyzer, and then show you how much more effective the real-time spectrum analyzer is for identifying these sorts of signals and looking for interference issue. So the first thing you do is you need to go to the mode key, and then in the mode key you will see the functions here you can select. So if you look for SA, which is the spectrum analyzer, we'll hit SA and that will load the spectrum analyzer. Okay, so that just only takes a few seconds. So let's zoom in on the area around where these signals will be present. So in this case what we will do is look at frequency, and we will enter 2.45 gigahertz, so just 2.45 gigahertz, okay? And then we'll also look at just a smaller span, so we'll choose in this case 100 megahertz of span. So if we hit the frequency span key here and select 100 megahertz, okay. So when we are looking in the spectrum, and you will just see the occasional bits of information popping up very briefly, so we'll make some other just refinements to the settings, and particularly in terms of the dynamic range of the instrument, because we are only looking with just a small antenna. So if we go to scale amplitude here, and we select attenuation and key in 0, so that removes attenuation from the front of the instrument. We'll also bring the reference level up a bit higher, so we go reference level minus 20, okay, dBm. And the other thing we will do is we can turn on the preamplifier as well. Okay, and so that's probably about the sort of best display that you like to get. So what we're seeing here is we're seeing combinations of the two Wi-Fi signals in our building. Other bits and pieces, there's Bluetooths popping up in there, pretty hard to see, but that's the sort of thing that you will see with just a standard spectrum analyzer mode. Okay, so what I'm going to show you now is how to also look at these signals in real-time spectrum analyzer. Okay, so if we come back up to our mode key here, and you'll see here is real-time spectrum analyzer. All right, so we'll hit real-time spectrum analyzer, and the machine will reboot into the real-time spectrum analyzer mode. Okay, so once again we need to set those parameters that we just set before. So we look at frequency, okay, and we go 2.45 gigahertz. Okay, we're automatically looking at 100 megahertz of span in this case, so we don't need to change that, but we do need to make the changes to the amplitude. Okay, so if we hit scale amplitude, our reference position minus 20, okay, go back, cancel that one, sorry, our reference level, that's what I should have said, minus 20 dBm, and our attenuation 0, which it looks like it is, so that's fine, and the preamp on. Okay, turn that on. All right, so here we have that same piece of spectrum now in the real-time spectrum analyzer mode. So what real-time spectrum analyzer does is uses FFT to be able to capture the spectrum very, very quickly, rather than takes a chunk of spectrum and digitizes it rather than sweeping. And so what you'll see now is those signals far more effectively, and what you'll also see is the different layers of signal, if this will stay in focus. So you'll see here how the various signals are all sitting at different points in the spectrum, and which ones are overlaying and popping up over the top of each other. So this should help you in terms of identifying, say, the signals from your device, the signals from other things that may be around the area, and which ones may be causing interference with each other. So this is what the spectrum typically looks like in these spaces, because these are just obviously generic sort of publicly available bands, and so you do have all of these signals sitting there at the same time, and reliance on the various pieces of equipment to be able to just track and identify the signal that you are looking at, or that the path you're looking at, rather than everything else. There are some modes that you can look at here. If you go into different menus and displays, you can look at various things around how the information's displayed, what type of, so for example, one of them is a sort of a time-based system, which is a spectrogram here, for example, which allows you to sort of track the duration of signals, and it uses colour to grade the amplitude of them to give you a slightly different perspective on what's happening in the band. But you'll need to experiment. You can change the span, the amplitude, the bandwidth, the various parameters to try and identify what's happening around your signals and what else might be there. Okay, so that's a short video. Hopefully that just sort of gets you started on how to quickly get the machine up and running, and to use the two different types of spectrum analyzer for this sort of work.